Well, hello everyone and welcome to a new video. In this video, we're going to be talking about subnetting. Now, before I get into the technical side, let's just have an idea about what is subnetting and why is it important. Now, let me just start with this situation here. Imagine that we actually want to build a network. And let's say we have 500 hosts in that network. So if you just imagine that I will have, let's say, a network, a single local area network. And inside this single local area network, I can have 500 hosts connected to it. Now, this, even though it's possible, not completely impossible, but it is possible. But this setup that I'm talking about here, having a single local area network where all my 500 hosts are connected, will lead to a lot of problems. Problem number one is management-wise, it's not going to be that easy to handle that big of a network. Number one. Number two, and this is the most important issue, when you have a network that has a lot of hosts, you will be facing what we call a broadcast domain issue. Broadcast domain issues, without me getting into the details of what is it, broadcast domain issue, it's a problem that will consume the resources of your network and the bandwidth of your network. And the bigger the number of hosts you have in a network, the bigger the problem of broadcast domain will be. You'll find that most of your hosts, those 500 hosts, are going to be busy most of the time processing data that will eventually just be dropped. So you're simply asking every one of the 500 machines here to be processing packets and traffic, and that traffic has only one end, which is simply going to be dropped. So I'm using those machines, I'm using their resources, their power, for nothing. So I'm wasting that resource. Number two, the bandwidth. There is a limit of how much data could be moved in a network, and the bigger the number of hosts that you have, the more consumption will be to that bandwidth, and you may end up having what we call a congestion network. So with that being said, having a network with a lot of hosts will lead to the problem of congestion network with the broadcast domain problem. So how do we fix this issue? And the idea here is not that complicated. It's a technique we use in our daily life. Whenever you have a big problem, what do you do with a big problem? You break it down into smaller problems. And that's what we're going to be doing here. And instead of having, let's say, one big local area network, let's just break it down into 5 or 10. So I can have, let's say, one network here, one network here, one network here, one network here, and one network here. And let's just make them 10. So another network here, a network here, a network here, and here. So those are my 10 local area networks. And I remember here, we said we have 500. So every single network will have 50 hosts. So with that being said, now you can see that for each network, instead of having a single network with 500 hosts, now we have multiple networks with only, let's say, 50 hosts. So the broadcast domain problem for each one of those networks is going to be significantly low comparing to that one big network that we had with 500. So we reduce that broadcast domain issue into those smaller networks, which again, as I said, the less the number of hosts you have there, the less the problem will be. So we still are going to have a broadcast domain, but it's not going to be as effective as if we have 500 machines. Now, once you break down your big network into those smaller networks, the only issue left is simply how do I get those networks to be connected? And the answer here will be using routers. So I can bring a router here, a router here, and a router here, and I'll just get them all connected. So for example, those 4 will be connected here. Those 4 will be connected here. Those 2 will be connected here. And of course, after that, those routers will be connected together. So that way, any host from any of these 10 networks will be able to communicate with other hosts. Now, you may ask the question, well, by doing that, do we still have the problem of the broadcast domain? The answer will be no, because any type of broadcast message that may move from one of those circles, the local networks, to the router simply will drop it. So it will not allow it to go everywhere else. So a broadcast domain message issued for a network, let's call it A, will only affect machines in network A. So This is achievable by applying what we call subnetting. And subnetting is one of the most essential skills that anyone in networking need to know. And unfortunately, it's one of those topics that I see a lot of students struggle to understand. So my goal in this video is to show you multiple ways and multiple methods to get the job done using different scenarios. And whatever method sticks in your head, just go for it. Okay? Now, the idea here is very simple. We are simply going to start with having one network IP address, the one that I'm giving you here, and your job is simply to break it down into those small, like for example, in this network that you see here, I'm just going to put this shape around it. This, you can look at it as a single network with an IP address, and in this case it's going to be, for example, this IP address. But what we're going to do, we're going to break down this IP address, so we will assign an IP address to this network, 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 and same is applied here, and applied here, and applied here. So every one of those small networks will have its own IP address, okay? So it's going to be distinguished and differentiated from the other networks, but at the same time, they all together share the same one big IP address. So my task here and my job here is to start with this IP address that I gave you for the whole network and break it down into a number of networks. And in this case, I told you it should be 6. Now, as I said, I'm going to give you 2 scenarios with 2 different prefixes. In this case, the first prefix I'm going with 25. The second one I'm going to go with a different prefix just to show you that when you have a situation like what I'm going to cover, how do you handle it? And when you have a situation in another situation, how do you handle it? Either way, it's not going to be that big of a difference. But I've noticed a lot of students, they get confused when they see something different from one example. So I'm going to cover 2 scenarios with 2 different prefixes. And then after that, I'm going to show you that how do I answer the question and how do I apply the subnetting using 2 different methods. One of them is going to heavily relies on what they call it, binary converting and logical operations. And that part I find a lot of students get confused about. And the other one, which I'm going to try to avoid as much as possible, of binary converging and logical operations, and make it more toward simple math. If you understand this method, go for it. If you didn't understand whatever method you'll understand, stick with it and you should have no problems. So let me just clear my screen and let me start by stating the obvious here in this question. What I do have here, I want to create 6 networks. So when I'm going to come here, I'm going to create those 6 networks. So I'm going to say net A, and then we have net B, and then net C, and then net D, and net E, and then net F. So those are my 6 networks. I'm going to assign an IP address to each one of them, of course, and then I'm going to have to figure out how many hosts I'm going to have for each network. Now, let's start with the method where I'm going to be doing a lot of binary converting and logical operations to figure this out. The idea here is very simple. We are going to start with the IP address that I have here, and if I'm going to put it in a form, before I put it in a form, let me just look at the prefix here. The prefix is 25. 25 simply, again, if you go back to the 2 videos that I created previously, it's a 25 ones followed by 7 zeros. Again, this is the subnet mask. So if I want to put the 25 prefix in a form of a subnet mask, it's simply going to be 255.255.255.128. That's the subnet mask. How did I get that? Because again, 25 simply means I got 8 ones here, and then I got 8 ones here. That will make it 16. Now I'm not counting. I'm just doing it really fast. This is 24. This is 25, and then I got the rest of those 7 zeros. This is again my subnet mask. This is in binary. This is in decimal. How did I get all this information? From the fact that I have 25 here. From 25 is telling me that I have 25 ones followed by 7 zeros. And we said whatever zeros were in your subnet mask represent the network host portion, sorry, and the ones represent the network portion. Okay. Now, with that being said, let's just take this out. Let me just take it out, and I'm going to write it down somewhere else. With that being said, now I can come here and just start listing it again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, and then 7 zeros. 1, 2, 3, 1, 2, 3, 4. Okay. Now, what I need to do, this is very, very important, is that I need to put this network IP address in binary as well. And to do so, instead of me doing that, let me just do it. 192 is simply 11000000. 168, I believe, is 128 plus 632. Let me just put it here, 128 plus 32. No, that's not it. 168. Maybe 64. Let's just put it 60. No, that's 192. If I put 32, that will make it 0, 6, 1. So it's not. Okay, we're getting somewhere. Plus 8. So that simply, it's 1, 0, and then 1 for 32, 0 for 16, 1 for 8, and then 4, 2, 1. So this is the binary representation for that number. Let me just clear this away. And then after that, what do we have? We have 100. And you know what? Let me just save some time. I'm going to use a calculator. If I go here, decimal, we got 100. And 100 is simply 0, 1, 1, 0. So let's go ahead and do that. 0, 1, 1, 0. And then after that, we have 0, 1. So we got 0, 1, 0, 0. Of course, and then 0 simply means they're all zeros. So 4, 1, 2, 3, 4. This is me converting my prefix to the subnet mask in binary, and this is me converting my IP address into a binary. Now, we said before that the place where the first one in the subnet mask flipped from 1 to 0, this is the line that's going to separate the network portion from the host portion. So this is the host portion here, and this is the network portion here. So let's just put N, P, and this is H, P. Okay, now, at this point, nothing new. How do I figure out, how do I do the subnetting? Now, this is extremely important, and this is going to be the same in all methods that we are going to simply go with. The idea here is that you're going to have to ask yourself one simple question. How many bits from the host portion I need to borrow to the network portion to be able to generate 6 different networks? Now, you may think, okay, so what is that supposed to mean? Let me just show you what is that supposed to mean. Let me start with this. We have a very simple equation to answer this question. And that equation is 2 to the number of bits you're going to borrow should be greater or equal to the number of networks that you have, that you want, which is 6. So let's start very, very simple with the first one. And by the way, we're borrowing bits from the host portion to the network portion, and we start counting from left to right. So let's start with this bit. If we borrow this bit, that's a simple bit. So it's going to be 2 to the power of 1, which is 2, and 2 is not greater than 6, so we cannot, satisfy our need. So let's just go ahead and borrow 2 bits. So 2 to the power of 2, now we're borrowing 2 bits, it's going to make it 4. 4 is not greater than 6. So we ask ourselves again, well, how about 3? 2 to the power of 3, let's just do it here, 2 to the power of 3 is simply 8. And 8 is actually greater or equal to 6, so this will give me the answer here. The number of bits that I have to borrow is simply 3. Now that I know I have to borrow 3 bits, this is what you need to understand, that this is my old line that separates the network portion from the host portion. Now I'm going to have a new one. And that new one is simply going to be here. So this is going to go away, doesn't exist anymore, and this will be my new line. And let me just clean this area here. Okay, now with that being said, and let's just put some rules after this point. I am borrowing 3 bits. Let me just use this. I am borrowing 3 bits. Let's just go ahead and put some facts based on what we just concluded. Since I'm borrowing 3 bits, that simply means those are not zeros anymore for the subnet mask. Those are going to be flipped to 1. So let's go ahead and do that. So this is going to be 1, 1, 1. So here we go. 1, 1, 1. Now, previously the prefix was 25. And now I'm adding 3 to it. So my new prefix is simply going to be 28. That's, again, something you need to understand. So for each one of those networks here, and by the way, he wanted 6, but I was able to get 8. So I'm going to use the first 6 and the last 2. We'll just keep them on the side. So the new prefix that I'm going to get out of this operation is going to be now 28. So for each one of the networks that I'm going to be generating, each one of them will have a prefix of 28. So that will be number 1. Number 2, how many bits are left for the host portion? And in this case, it's going to be 4, because if you count them, this is the host portion now, it's 4. So the number of hosts I can have for each network is 2 to the power of 4 minus 2, and that will make it 16, 14. 2 to the power of 4 is 16 minus 2 is 14. So every single network will have a number of hosts that is 14. So this is 2 facts that we need to remember. So let me just take this one away. And let's start thinking about how do I generate the network IP address for each one of those. Now I'm going to show you 2 ways to get the job done. The first one, where I'm going to be doing a lot of binary work, which again, if you understand it, good for you. If you don't understand it, it's not the end of the world. There's another way that I believe it could be a little bit easier for you. So let's go ahead and cover both of them. So how do we do that? The first method that I'm going to go relies on those 3 bits that I have here. Remember here, this is the subnet mask and this is the actual IP address. So what I'm going to do, I'm going to take those 3 bits. So I have a bit here, and a bit here, and a bit here. And I have to think about the possible combination that I can have for those 3 bits. And here they are. They could all be zeros. This could be 0, 0, 1. This could be 0, 1, 0. This could be 0, 1, 1. This could be 1, 0, 0. This could be 1, 0, 1. This could be 1, 1, 0. This could be 1, 1, 1. So those are all the possibilities that I have here. And if you notice, there are 8 actually. So it could be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now, if you don't like to go and do whatever I just did here, you can do it differently. Now, since I'm borrowing 2 bits, so that's simply telling me that I have 8 different combinations I can have, which is, again, it's coming from 2 to the power of 3. Okay? Since that's the case, I know that I'm going to have 8 different combinations for those 3 bits. And what I can do, I can start with the first one, 0, 1, 0, 1, 0, 1, 0, 1 for 8 times. The second one, 0, 0, 1, 1, 0, 0, 1, 1 for 8 times. 0, 0, 0, 0, 1, 1, 1, 1, 1. As you can see here, this is repeated 8 times. Okay, now with that being said, for each network of these networks, all I have to do, remember here, is to pick one of those 8 options and replace it here. Okay, so for the first network, I'm going to go with 0, 0, 0. So let's just go ahead and type it here. Now, number 1, remember, when I put 0, 0, 0 here, all I have to do to convert this whole thing back to binary, to decimal, sorry. So by doing that, I will get 192.168.100.0/28. So that's network 1. Network 2, what I'm going to do, I'm going to use the second one here, which is this one here. So what I'm going to do here, let's just go and actually do that. This is going to be 1 instead of 0. Okay? So if you convert this number here, 0, 0, 0, 1, 0, 0, it's going to be 16. So let's go ahead and do that. 192, 168, 116, backslash 28. Now the third one, what we're going to do, we're simply going to go ahead and do the same thing. Now we'll put this back to 0 and change this one to 1, because again, remember here, this is going to be 1, this is going to be 0. I simply use this one, and I'm using this one right now. That is 32, I believe. Yes, that's 32. So let's go ahead and do that here. 192, 168, 100, and then 32, backslash 28. Now, the fourth one. And let's go ahead and clean. The fourth one is when I have all of them. Sorry, those two are ones. So this one and this one. So we covered this case. Now we are at this case here. And that is, if you convert this back to decimal, you are going to get 48, I believe. So 192, 168, 100. Let me just do the math again. 16 plus 32, that's 8. Yeah, 48. Backslash 28. Let's go back here, and now remember here we covered the fourth case. Where is it? This one. And now we're moving to the fifth case. Now for the fifth case, we need to clear this. And we're simply going to have a 1, 0, 0. Oh, wait a minute. I made a mistake. Did I? No, I didn't. Sorry. This is 64. Yes, my bad. I thought that I made a mistake. This is 64. Okay. If I convert this to binary, I am simply going to get 64. So 192, 168, 100, and then 64, backslash 28. Now, so I am done with the fifth network. So let's clean this one here. Now remember here, we already finished this one, and now we are here. So we're going to go with 0, 1, 0, 1, all the way zeros. Now, if I come here, 192, 168, 100 dot. Now this one, if I want to convert this to decimal, it's simply 64 plus 16. This is 0, this is 7. Yep, so 7t, so let's go ahead and put it here. 70 backslash 28. Let me just move it to the right place. And I'm done. Of course, if I want, I can continue and get the rest of these networks. I can get this one and this one if I want, but he just asked for 6. So here are your 6 network IP addresses. Now, let me just clear some of this section here. Let's clear this section here. Clear this section here. And this is my answer. Now let me just go and use the software that I talked about the other day, and let's just give this a try and see if we made any mistakes or we got it right. 168.100.0 backslash 25. And now we're going to subnet it based on the network requirements. How many networks do you need? I want 6. Click yes, and here they are. Oh, wait a minute. This is 80. I made a mistake. It's not. Yeah, I don't know. What was I thinking? So this is right, except the last one, which is again 80. Let's go ahead and double check, because it's the one that you see here. So that's 64 plus 16. So this is 0, and this is, yep, 80. I made a mistake, so let me fix it here. And I'll just come here and put an 8. Let me just move it a little bit. And here we go. So as you can see here, we got the job done, and it was matching with what we did here. And it's okay. It's good. Okay, now let me just go and show you how can I get the same results in a different way. And I hope the second one will be a little bit easier to follow. So let me just copy this, and I'm going to put it here, down. And I'm going to show you how exactly this is achievable. Now, the answer for that, we'll go through a few steps. Number one, I know for sure for each one of those networks, my prefix is going to be 28. I don't have to do anything. But here's what I'm going to do. I'm going to take this number that you see here for the number of hosts, which is 14, but I'm going to add to it two IP addresses because, again, we said how do we get this number to start with? It's 2 to the power of the number of host portion, which is 4, minus 2, and that basically was 16 minus 2, and that is 14. Now what I want to do, I want to use the 16 all together. I don't want to subtract those two from it. So I am going to actually, as I said, to use the whole 16. So whatever the number of hosts, usable hosts that you have, just add to it so you can use it in the calculation that comes next. So here's what I'm going to do. I'm going to start by creating a mask. Okay, and this mask that I'm creating is going to be simply 0.0.0.0. Okay, that's my first step. Now, I learned that the prefix is going to be 28. So my first IP address is simply going to be whatever the IP address that you have here with the new subnet mask. But it's not exactly like that. It's like this. Let me just put it this way. The first for network A is simply going to be 192.168.100.0 prefix 28 plus this number, which in this case, this is 0000, so no change is going to be applied. So the first network IP address is simply going to be 192.168.100.0.28. Once you're done with that part, we move to the second one. Now, before we do the calculation for the second one, and I want you to pay attention to this because this is very, very important. We are always going to go back and use the first IP address, which is this one here. Which is, again, if you think about it, it's the same thing here without the prefix. So we're always going to use this IP address. So here's what I'm going to do. Very, very important. I'm going to go and add, what is it? I'm going to take this mask here, the 0.0.0, and I'm going to add 16 to it. Remember the 14, we added 2 to it, so 16. So then mask is simply going to be 0.0.0.16. And then you take this number and you add it to this number here. And that will give you the network number 2. So if I come here and put it this way, 192.168.100.16/28. Now, for the third network, what I'm going to do, I'm going to simply add 16 again to the same network. So to the mask. So you come here and add 16 to it. It was 32. It was 16. So you add. It's going to make it 32. And you take the 32 and you add it to this network IP address. And what do you get? You get the third network IP address, which is going to be again 192.168.100.32/28. And after that, I repeat the same thing. Add another 16 to it. And what am I going to get? I'm simply going to get the 48, I believe. So this will make it 48. You take the 48, you add it here, and you will get the network IP address for the fourth one. Yep. 192.168.100, and then 48/28. Now what do we do after that? We're simply going to do the same thing. We're going to add 16 to the 48, and that will produce 64. So 48, 64. You add the 64 here, you get the IP address. 192.168.100.64/28. And what do I do next? Can you guess? I'm going to do the same thing. I'm going to add 16 to the 64, and that will produce the 80. And then you take the 80 and you add it to the original IP address, and what do you get? The fifth one, and that's simply what I need. 192, 168, 180 / 28. And that's it. Now, this case, it worked with no problems. Now, but there's something I have to tell you here, because this is a case that you may be facing in the future. At a certain level, you're going to keep adding, let's say 16 here, to this number. Whenever this number that you have here reaches to 256, okay? Whenever the number that you have here reaches 256 or greater, 256 or greater than 256, this is what we do. For example, just imagine the number that we had here, let's say it was 2, 4, 0. Just imagine that was the case. I got to a point where the number that I have here is 240. And then after that, I added 16 to it. So what do I get? 256. The moment you reach to 256, you set it back to 0. And then you change this 0 that you have here to 1. Now, this is not applicable here, but I'm talking about in the future. In the next video, I will show you a case where you may actually get to that point. But the idea here is, as you're adding those numbers to this mask that I just created, whenever the number that you have here reaches to 256 or greater, you simply have to wipe it out, okay, set it to 0, and increase the number that's next to it by 1. You keep repeating the process. If you get 256 again, set it to 0 and add 1 to here. So this is going to be 2, and you keep going in that manner. So this is the first example. The second example, I'm going to give you a prefix of 22. Or you know what, let me just make it 23. And we'll see how things are going to go from that point. So thank you for watching. See you guys later.